What
Yeah.
did we do last time? So you said we were starting to sort of get into the basics of networking,
Yep.
and right. And can you be a little bit more specific regarding what we've actually seen?
Yeah. What is networking? What is a subnet? What is a subnet mask?
Right, right. And so like
Also,
the overall like the underlying ways of in which the IP protocol functions, right?
exactly.
Okay,
IP addressing basics. Basics.
exactly. So that was the whole point. Is the IP addressing. That's the keyword I wanted to hear. Great. Scout, maybe you want to elaborate on that? Last week we talked about IP addressing, subnets, and whatnot.
Correct. So what I would like to add to that is basically we were working with a packet tracer to basically be able to build out systems to show how one subnet can communicate to another. Or
Mm-hmm.
sorry, multiple devices can basically ping each other and send information um, over a subnet, and then if they go to another subnet, it has to go through a router where the IP address has it's basically a sender and a receiving address. That way, it can send information back and forth.
Correct. So yeah, the general idea, and we're
That
gonna
was the
work.
general idea, not the
Yeah,
specifics. But
absolutely. By the way, have either of you had time to work a little bit more with Packet Tracer?
I still remember a lot from last time, but at the same time, I haven't really had too much time to be able to work it. I've been working pretty much all week.
Mm-hmm. What about you,
Neither,
Daniel?
neither did I.
Neither did you. Okay, that's fine. By the way, like no problems with that. We're gonna go. I'm hoping we can go at a pace where there won't be too much homework necessary.
I'll try to touch it a couple times this week. I'm off the second half of tomorrow, so I can kind of dive into it a bit more.
Great. So can you see my screen right now?
I'm pulling it up now. Uh, yes, I
Yep.
can.
Yep.
Okay. So to sort of summarize what we've seen last time, the general idea was that you were correct that the main idea first we started with like individual PCs. So like if I have two computers and I sort of plug them into each other and I give them IP addresses like 192.168.11/24. Do you remember what the slash 24 stands for?
That is. Oh God, let me check my notes because I wrote it down.
The mask.
Let's see,
Yes, that is the mask.
I forgot that that's what it was called,
So the
but
mask or subnet mask. Yes. What is the mask used for,
oh,
Daniel?
there it is.
Daniel?
To sorry. To indicate where the prefix of the address ends and where the identifier of the machine begins.
That is absolutely perfect.
Yeah, that's a good way of putting that.
Right. So the idea is we have the subnet address, which is like the street name, and then we have the individual address within that street. So the prefix would be in that case the prefix would be the first, in this case, the first 24 bits, meaning the first 3 bytes of the address. Correct. And so for instance, if I was to give so is tell me if this is a valid IP configuration for the second PC here. So 192.168 102/24. Is this like will I have IP connectivity between the two? What do you guys think?
I'd say yes in this situation. Although I will say if you go too high on the amount of subnet masks, then two of them are going to be reserved for the system. But that's
I
neither here nor there.
I think that maybe not.
Okay, so let's run through this, all right? So I think it really helps to really understand how a computer is actually going to process what we're going to try to do. So to test if we have IP connectivity, let's imagine what would happen if we were to ping from one PC to the other. So let's say this is PC A, this is PC B, and we're trying to ping from A to B. So what happens?
Okay.
Well, we're saying, so we are at PCA with this IP configuration, and we're telling PCA, hey, ping this second IP address. Ping the address 192.168.1.1.
Whoa, I just heard all of your audio. Like, I'm hearing every like fourth word.
Oh, is my audio kind of buggy for
Okay,
you too?
there we go.
I can
It was
hear
buggy
you.
until
I
a
can
second
hear you.
ago.
Okay. So, we want to ping from 192.168.100 to 192.168.1.1. Now,
Okay.
if you remember correctly, there is one thing I mentioned, like kind of briefly towards the end of last week's session. What is one of the first things that the PC is going to do before sending anything? Like, let's say I am PCA, and I want to send something towards that IP address, towards the IP address of PCB. But I don't, like, it's not like I know that PCB exists. Like, from my perspective, all I know is that, like, I have an Ethernet cable plugged in my butt. That's all I actually know, right? I don't know my neighbors until I go see them or something. So I don't know that PCB actually exists. All I know is that there's this IP address that someone is trying to ping from me. So what is going to be the thought process?
So it's going to ping the other one, but it also has to make a round trip.
Okay, but before I ping anything,
you have to check if it's on the same street.
Exactly, right. So
okay.
It's like you're trying to deliver butter to like a neighbor or whatever, or a friend. First thing you want to know is, like, is that friend my neighbor, or does he live kind of far away? So, like, do I have to take the bus, or, like, can I just walk there? So in this case, if I'm PCA with the information that I have, that information being my IP address, my mask, and the destination IP address, and that's it, what would be my conclusion? Is the destination IP address in my network or not?
It would be. Wait,
Okay, so how would I determine if something is in my subnet or not? How do I determine that?
And this is before pinging, correct?
Yes. It's just trying to figure out where to send it. Like, I'm just trying to figure out, am I gonna take the bus or am I gonna walk there? And by taking the bus, I mean, am I gonna ask the gateway to sort of deliver my packet, or am I gonna deliver it myself? That's kind of the idea.
Okay. Thinking through it. Let me open back up my.
So what do you think, Daniel?
I'm thinking that first the machine would check the mask and say, okay, I have an IP address, and the mask says that 3 bytes are the prefix. So now in these bytes,
the PCA would check its own mask, correct? PCA would check its own mask and its own IP address. And from its own mask and its own IP address, it would determine, okay, my street is street 192, 168, 100, 0/24. That's my street name. Does that make sense?
Okay.
Does it make more sense for you as well, Scout?
To a degree, you're basically using the first 3 bytes just to see how close they are to each other, correct? Or
so I'm more specifically, I'm trying to think of all this exclusively through the perspective of PCA.
Okay.
So I don't know that PCB exists. I don't know where it is.
Okay, so I mean, it doesn't matter if it's like next door or if it's 3,000 miles away. It's technically, we don't know where it is.
Yes, and I'm trying to get to it, assuming like everything was configured correctly. And we're trying to figure out if this is a correct configuration that would allow a ping between the two. So I'm PCA, and I can actually guess my own the subnet in which I belong, right? Like I can take a guess that, oh yeah, from the IP address that I was given and the mask I was given, I can guess my own subnet address, right? Like if you live 101 Programmer Street, you know that you live on Programmer Street, and you know that if you try to reach anyone that's also on Programmer Street, you can probably just walk there. You don't have to take the bus.
Okay.
Okay. So the idea now is, I know what my subnet mask is. I know what my my subnet prefix is. It's 192.168.100.0/24. And now what I do is I check the destination IP address. So I don't know the destination mask or anything. I just have the IP address. That's important. So I just know that I'm trying to deliver something to 192.168.100.1. Is it 1? Oh, wait, no, it's not 100. Excuse me. Let me fix that real quick. 192.168.1.1 slash. Actually, never mind that. I'm trying to deliver something to 192.168.1.1. Is 192.168.1.1 part of the subnet 192.168.100.0?
No.
Oh, because it's 100 instead of 1.
Exactly, and because like essentially I would need the first 3 bytes because it's a /24, remember? So I'd need the first 3 bytes to be the same.
Oh yeah, those have to match. Okay.
Right. If those first 3 bytes had matched, then they would be on the same street.
Okay.
But here, because they don't, my conclusion is
okay. I wasn't thinking through it.
Right. My conclusion is they're not on the same street. We're not like this destination IP address is not on my street. And so I have to take the bus. I have to ask my gateway.
Got it. Now, it's like when you have like
yeah, go ahead.
It's like city, subdivision, street address. Like it just needs to make sure that it's close enough, otherwise it's somewhere completely different.
So the really funny thing about this kind of lesson is I use this sort of postman problem, this postman analogy all the time, including when we get into much more complicated routing protocols like OSPF. Instead of just being like, oh yeah, you have like streets and like houses within streets, and then I go like, okay, there are cities and there are countries, and like that's actually how I explain it, and it makes a lot of sense and it's really fun. So yeah, the analogy actually goes pretty far.
You have no idea how many like car analogies I have to use to sell computers to people, so I get you.
But yeah, I'm hoping that this makes sense, right? I'm trying to figure out if I'm going to take the bus or if I can just walk there. And I can determine that just from A, my own IP configuration, which lets me determine my own subnet, and B, the destination IP address, and I just see if like the first whatever bytes of my mask match, right? In this case, they don't, so my conclusion is, okay, must be on a different subnet. In this specific case, that would mean that would mean PCA would look for its own gateway before sending it. However, there is no gateway.
Okay.
And we know what happened. What happens when we try to contact something from a different subnet, but we don't have a gateway. We just don't send anything. So, if you were to do this exact configuration, it wouldn't work. The reason why it doesn't work is because you have PCA and B in the same subnet, but their IP addressing suggests that they're not in the same subnet.
Understood.
Right? Does that really make sense now?
Yeah.
Okay. So now, if I give you another example. God. Okay. If I was to say that, let's see. Instead of being 192.1, instead of being 100 here, I said 1. In this case, would the ping pass?
Yes.
Yes.
Because it's within the same
subnet. Yes,
yeah,
absolutely. Well, perfect. Okay. Now let's add a router into the mix. So here we're going to add a switch. And then a router over there. Do you remember what a router does? I think you mentioned it briefly, Scout.
It can connect subnet or subnets to, sorry. It can connect subnets to other outside subnets.
Right. It's like a bridge between subnets.
Correct.
Okay.
Yeah.
So could I have something like this? Let's see. Another PC. Let's see. I say this one is 10, 0, 0, 100/8. Okay, let's say I just leave it at this. And let's say this is PC C. Do I have IP connectivity between PC A and C? Assuming these are all the IP addresses I have configured. I haven't configured anything else.
No.
No, why not?
Because the computer doesn't know where to send the package if it's in another subnet, and neither does the router.
Okay, I see what you mean. And what do you suggest? What do you suggest we configure then, if we're missing something? Scout, if you have an idea, also don't hesitate.
Okay, no problem. So we need to have a return, like we need to have a sending and a return address on the. Is the router the issue here? Because like we have the two different subnets.
So
we just need
so I'm gonna give you a hint. There are two things we need to configure here. There are two things missing.
We need to configure the router, and then there's one other thing I'm missing.
Right. So you're correct, Scout, that we need to configure the router, and I think Daniel was onto the other thing.
Yeah, we have also to configure the computer A to give the package of information to the router.
Right. And do you remember the name of the field we have to fill?
No. Sorry.
So Scout, do you remember? It's the field we need to fill out to know, like, it's like, hey, what IP address do I need to pass the packet to when I want to leave? Yes, exactly. The gateway.
Thank God I took notes.
So Scout, you're correct that we need to configure the router. More specifically, we need to configure the router's IP addresses here and here. And we need to configure our gateways. I'll just write GW for gateway. So gateways for A and B and C, right? Because as we've demonstrated last week, if you remember, it's not enough for the packet, for the ping to get to its destination. We also need the packet to be able to come back. And if C doesn't have a gateway, it won't be able to send the packet back.
Okay, that's right. Like there needed to be two gateways, that way I have something to connect to properly.
Exactly. Okay. So are we up to speed now?
Yes.
Yep.
Okay. So we're going to move on to today's lesson, which is we're going to try to be a little bit more technical tonight. Let's see. Okay. So let's get started on the IP packet and IP routing. So first of all, the IP packet, I've used this term very frequently. Generally speaking, we talk about an IP packet. It's a chunk of data, right? That is, let's say, packaged in a very specific way. Specifically, you have like the payload, which is like the data. So that would be what the application is actively trying to send to the other computer. So like if it's a ping, for instance, the data would be the content of the ping. And then you have a series of headers. The first header is almost always the Ethernet header. Now, Ethernet, you've heard the term Ethernet before because you have an Ethernet cable, but Ethernet is also a protocol. However, in this lesson, I don't want to spend too much time talking about Ethernet, in the sense that it's very interesting, but if the goal is just to understand how your home router works, you're not actually going to do a whole lot learning about the Ethernet protocol. So I decided to skip over it. The second header will be the IP header, and that is the one that we're going to spend some more time on. And then occasionally, not always, but sometimes, you also have the TCP or UDP header. It's going to be either TCP or UDP. Those are protocols that we will talk about in details, but again, at a later time. And then you have the Ethernet trailer, which is basically, you can think of it as like another piece of the Ethernet header. It's just part of the Ethernet protocol, which again, we don't really care much about. So we're not going to talk about it too much. So what I'm going to try to look at now is, okay, like it's great and all. There's this IP header and all of that. Like how does that help me at all? Well, it's going to be useful when you guys are going to be using Wireshark. Wireshark is a software that
I already own that software.
Fantastic. That's a software so it captures packets. Yep, and not just packets. Actually, technically, it captures all the frames. The terminology is a bit complicated, but just if you say packet all the time, you'll be fine. It might be technically wrong at times, but it's fine. It doesn't matter.
I used it once.
Well, here's the thing. So Wireshark can be used for other things, like capturing USB packets as well. But for the most part, it's used for...
I forget what I used it for, but...
Yeah, for the most part, it's used for network packets. And in particular, I've picked here a screenshot. If you look carefully,
that looks semi-familiar.
Yeah, I've picked a screenshot. If you look at the line that's highlighted in blue, you can see Internet Protocol version 4. That's IPv4, right? So you see there is like Ethernet, and below it there's Internet Protocol version 4, and then this whole thing is like a little bit detailed because it's like opened up, and then under that you see User Datagram Protocol. That's UDP. So if we go back here, we see we have the Ethernet header followed by the IP header, followed by, in that case, a UDP header. Right? And that's exactly what we have. We have an Ethernet header followed by an by an IP header followed by a UDP header. Does that make sense?
Yes. It's just vertical instead of horizontal in this case.
Yes, but it's the same order.
Yeah.
Okay, and the really cool thing is you can use this right now and capture actual packets. Like, here's the really cool thing you can do. You can download Wireshark, run it, send a ping to, for instance, Google servers or whatever, filter for ICMP protocol. If you remember, ICMP is the protocol that's responsible for pings. So filter your because obviously your network card catches a lot of packets. So you'd want to only filter like the ICMP ones so that, you can see what happened with the ping you just sent. And you would be able to see what IP header those packets have. In particular, there are two fields in that header that we particularly care about, and those are the source address and destination address. So think of those as, think of the IP header as sort of an envelope. You have the letter you're trying to send. That would be the data, you know, like what I wrote, what the application is trying to send, the content of the letter. So that's the letter you're trying to send. And then you have sort of a series of envelopes around it. So you have first you put it in a UDP or TCP envelope, then in an IP envelope, and then in an Ethernet envelope. But if you look at the IP envelope, you're going to see a source and destination address. The source address is the person to whom you have to send a receipt. The destination address is obviously who you're trying to send the packet to. Does that make sense?
Yes. Okay. So it's
So
you have your source and destination. Got it.
Right. So if we have a look at like what it would do in theory, I would have, let's say, two PCs with IP 10.0.0.100 / let's say 8 and 10.0.0.101 / 8 interconnected. When I send a ping from PC A to PC B, what happens is that it's like I just wrote a letter, right? An ICMP letter. So I get, again, ICMP is the protocol responsible for a ping. I just wrote an ICMP header, an ICMP letter, and put it in an envelope that would be an IP envelope with on it the source, which would be 10.0.0.100. I'm skipping a few zeros so I can actually write it. And destination being 10.0.0.101. So is that clear? Yeah?
Yes.
Actually pretty straightforward, right?
Yeah. So next would be the what is that? The UH the TCM and UH.
The TCP is what is that? Okay, so in the case of ICMP, so here's the thing. In reality, no. For a few reasons. First of all, in the case of ICMP, there is no TCP or UDP header. Because, like, ICMP is literally just about IP. That's it. That's all it cares about. And the second reason is, even if I needed a TCP or UDP header, that's not the ordering in which I do it. I would first put the letter in the TCP envelope, and then I'd put that in the IP envelope, and then I'd put that in the Ethernet envelope. Right? So I'd start from the data and then outwards. Does that make sense?
It's like an onion.
So, okay, this concept I didn't want to get into because it's a little bit more abstract. But if you want to do some more research on it, it's a concept called encapsulation, where the idea is you have your data and you're trying to encapsulate it in several headers at a time in a very specific order. But again, I don't really want to get into that because if I start talking about encapsulation, I have to talk about the TCP IP stack. I have to talk about the OSI model. I don't want to get into that. It's not strictly necessary for what we're trying to do. But the bottom line, if you want to know what's happening with your packets, run Wireshark look for the IPv4 header, the IPv4 section, and you will see source and destination IP addresses.
Oh wait, really? Oh, let me.
And you can do that like actually right now. Like you could literally just start capturing packets. Like you can run Wireshark, start capturing packets, and see, like you can look at the source and destination IP addresses for all those packets. And for instance, maybe in the mix you'll find a few Discord packets, right? Like so the really cool thing is you can actually use that. Let's like okay, so let's say you have the source and destination address. The source address might be like your PC, right? And that's not really helping. And then you have like a destination address, and you have no idea what it is. You can actually use a service like Whois. So literally, like it's literally WHOIS. So you look for a Whois service online. You can figure out just from an IP address, you can figure out the domain name, you can figure out who owns that domain name, where it is located, and a bunch of other information. So like you could literally pick a specific packet that your PC just sent and try to figure out where that packet was destined. And maybe you could maybe you just caught a Discord packet, for instance.
Okay, I'm running it right now. It's been a while since I've run it. Let's see.
So yeah, this is in practice. I personally very rarely use Wireshark. I don't feel the need to actually do that, but it's a good learning experience to have like a look at what am I actually sending on the wire. You know, it's no longer theoretical, it's very technical, it's right in front of my eyes, and I know exactly what I need to look for. Now, obviously, the IP header is quite complex. As you can see, there's a bunch of fields. Like there's the version, header length, there are flags, the fragment offset when you need to fragment your packets. Like there's a bunch of fields. But what we are mostly interested in is source and destination IP addresses. And when that's what you're looking for, you know where to find it. Also,
okay.
if you notice at the very bottom of the capture, the packet that you captured, you can see the hexadecimal content of the IP packet that was sent. And so if you remember in the application, I asked you guys like how comfortable you are with binary and hexadecimal. And
hex I'm less familiar with, but at the same time I do know it's based off a 16-digit.
Exactly. So it goes from 0 to F. But like it's not strictly necessary, but it's just to say like it's so baller to be able to read hexadecimal. Like I want to meet someone who has so much experience with Wireshark that just looking at the hexadecimal, he can determine the source and destination IP addresses.
You just blew my mind because I just realized one of the pieces of music software I've been using forever does all of its effects lists and everything based off hexadecimal.
Well, actually, yeah, there's for instance, a lot of software that is hex editors, for instance, are fantastic because essentially you have binary files, but like it's hard to read in binary. It's much more common to read those files in hexadecimal. So like if you work with like electronics and you're trying to, for instance, write to an EEPROM, it's very common to sort of use to use either a hex dump or a hex editor to actually modify the content of what you're trying to write. Like it's mostly when hexadecimal is most useful to know when you're dabbling with like very low level electronics, like really close to the machine. It's not really what we're doing here, but again, kind of funny. And you can be like Morpheus literally reading the Matrix live.
Oh god.
Anyway.
Is it a good read? No, I'm just kidding.
I don't know. Should ask him. So, all of that to say, we know that a packet is basically a letter. Okay, it has a source and destination address. Okay, so the process of delivering that letter, also called routing, is more or less a postman's job. But it's a weird postman job because it's like you have a postman literally running from your house to the destination. It doesn't go through a post office or anything. So it's kind of weird. But the idea is, how do you go from point A to point B? How do you go from the source address to the destination address? And we've already done a little bit of that, you know, like when we start talking about, you know, like you need to configure the IP addresses properly, you need to configure the gateways properly, you need to configure your router and all of that. And we've already more or less done like 90% of that delivery process, right? But there's sort of one situation that we have not talked about yet.
Okay.
So, okay, think about it this way. For now, we know that, so the router is obviously the one that the device that's responsible for routing your packets. So as I've explained before, the router is being the frontier between subnets. The router is kind of like a crossroads of several subnets, a crossroads of several streets. The router is aware of several subnets. It's aware of the subnets it's a part of. But what happens when you go beyond that? So what would happen if you had two routers? So let me give you an example. Let's say I have a router here, right? And I have another subnet right here. So to make it a little bit simpler, I'm gonna give, instead of specifying like individual devices IP addresses, from now on, I'm mostly going to just give like the subnet IP address, this like the network prefix. Is that okay for everyone?
Yes.
Mm-hmm.
Okay, so let's say this is 10.0. Yeah, let's go do that. 10.0.0.0/8. Two routers, double the upload and download speed. That's not quite how it works. I mean, it depends how you've configured your thing. It might be how it works, but it's probably not. That's actually, you know, now that you mention it, that is feasible, but it's actually so hard to do. So I'd say this is 10.0.0/8. This, we can say it's, what would be a good one? 1, 0, let's say it's 1, 1, 1, 1. Actually, no, that's kind of confusing. Oh, no. I am a bit clumsy. Okay, let's say 1, 1, 1, 0/24. I'm hoping I'm hoping it's not too confusing when I sort of use different masks. It's just, think of it as like streets being, like the bigger the mask, the shorter the streets. Think of it that way, right? It's not because it's just the size of the street, but it's like the inverse of the mask. Like the bigger the mask, the shorter the street, but that's about it. Okay, so like it doesn't really change our sort of map idea.
Okay.
Okay, and so this would be 10. Oh wait, I already have a. Okay, let's say this is 11. I'm gonna cheat a little bit. Change what we had. 11.0.0/8, and this is, we said 192.168. 10/24. Okay, so we have 4 subnets. Actually, you know what? I'm gonna redraw this a little more simpler below. So we have 192.168.10/24. We have 11.0.0/8. We have what was it? 1, 1, 1, 0/24, and we have, yeah, I know I made a face. 10
That's actually...
0 0 0.
I kind of love that. Damn. Okay.
Okay, and separated by routers. Wait, is that right? Or did I mess up something? Nope, there's only one router. Oh yeah, right, because that one is in 3 at a time. Okay, yeah. Are those potatoes IP addresses? Not quite. Those potatoes are subnets. So they're not individual IP addresses, they're more like streets, so sets of IP addresses. So one big router here. Okay. So now the question is, let's say someone tries to send a packet. So I'm going to draw just a letter, right? Someone tries to send a letter from, let's give those subnets, let's give them letters. So subnet A, subnet B, subnet C, and subnet D. With what we currently know, hey, what's up, Ty Lemons? With what we currently know, can the letter be delivered from subnet A to subnet C? Is that feasible?
Yes.
Yes.
Okay, I agree. It can be. Can it be delivered to subnet B?
A and B share the same router, right?
Maybe. What do you think, Scout?
As long as the router has...
Yeah, I'm not sure I represented properly, but like these are connected to the router like this.
Okay.
Oh yeah. Yes, as long as the gateways are properly set up, then yes, it could go from A to B.
Right. I agree. Totally can. Now, okay, I guess I'm gonna have to redraw this real quick. What about A to D? What do you guys think? With what we currently know, and assuming we're not doing any kind of weird black magic. Right?
Maybe.
The question is like, how, okay, walk me through your thought process. Why did you say yes when I asked, can you do A to B? What allows you to do A to B?
The packet pings through the gateway, makes sure the other end of the gateway goes to the other IP address, and then sends a round trip just to make sure.
Yes, but beyond just the gateways, what I'd like you to focus a little bit more on the router. There's a reason that now we have 2 routers. So what does the router do here? Remember the slide I showed earlier, where I said that by default, the router knows its neighboring subnets. So, but that's it. By default, all it knows is its neighboring subnets, or like the streets that he's a part, the street that it's a part of. Okay. What about the streets that are further away? What about the streets that the router is not a part of? Does he, by default, does the router have knowledge of those streets further away?
No, it can't. So
again, it's exclusively based on what we currently know. I'm not pulling any rabbit out of my hat or whatever. I'm not doing any magic tricks. Like,
I think that no, because
I just feel like there's info missing between one to the other that's keeping me from giving a straight answer on it. That's the only thing.
Yes, exactly. That's exactly right. by default, but like, let's just walk through this logically, right? If all I know is the streets that I'm a part of, right, then I have no idea that this street even exists.
Yeah.
And it's really that simple. So the answer is no. The router, let's say router A has no idea that the subnet D even exists. So if I am in subnet A and I ask router A, hey, can you route my packet to subnet D? Subnet A will look in its, and that's a new term, in its routing table.
Okay.
And we'll say, okay, I have no fucking idea where that is because it's not in my routing table.
It doesn't quite know where to route it. Okay.
Exactly. It doesn't know where to route it.
Okay.
So, yeah. Make sure you ask questions if it's not clear. Like, don't hesitate if you feel like you want to like just repeat what I just said to to make sure that you understand properly. If you want to do that, or if you have questions, don't hesitate to interrupt.
But then, how is the internet supposed to work?
Well, remember what I said. I said by default.
Oh.
Right. So we're going to do something about it. Now, what would let's say, again, let's take our road example again. Let's say the subnet is like a guy, like the router. Let's say the router is like, literally there's a guy standing at this crossroads. And like, he's literally, his job is to route you towards your destination, okay? And by default, he only sees what's next to him. So he only sees the street that are neighboring him. What would you consider doing so that he knows streets further away? Just don't think too far, like pretty simple. What would you do?
Make sure there's proper two-way routing, or would it go through a separate go through a separate router?
You're thinking too far. Literally, like there's a guy, there's a human being standing in the middle there, and he doesn't know. But like, let's say you are God and you're omniscient in this situation and you know everything, but you'd like him to know. What would you do? You tell him. Just tell him.
Yeah.
You go to the router guy and you tell him, hey, there's that street over there, and if someone asks you for that street, you send him that way. That's it. That's actually it. Okay? So like, by default, the router only sees what's next to him. But if you manually tell him where to find other streets, or more precisely, if you tell him, hey, if someone asks you for this street, you send him over there, he will just do it. The router will just do it. Does that make sense? So like, for instance, if we're manually telling router A, let's say I'm going to pull up my magic pencil. So we're actually doing black magics here, right? And I tell him, if someone, you'll forgive my terrible handwriting, someone asks for subnet D, send them to, send them to router B. That's a B. And this would be router B. Okay.
Okay. Also, I like chat's answer for how to properly get the router to send info. To
Bully router A until you find something. Yeah, that usually works.
Worse.
You know, there's a really kind of a funny joke in French where the word con literally means usually means stupid, kind of. It's an insult. But so you'd say a computer is very stupid because it only does what he's told to do.
Oh yeah.
So this is kind of the idea too. Like the router can't make guesses, but you just have to tell him. So in practice, what would that mean? Well, to understand what we're doing here is we are, and I'm going to use that term again, we're going to add a route to the routing table. So what we're going to do right now, and after that, I think we're going to take a break and we might stop after this. So we didn't exactly go as far as I wanted, but that's fine. What we're going to do is we're going to take a look at a quick look. I don't want to go too far here, but we're going to take a quick look at the routing table to really start to get a feel for what's happening there. So going back to this slide, by default, the router knows its neighboring subnets. Okay. In practice, what the router does is first, it looks at its own IP configurations to determine its own subnets. You know, if you remember, that's the same process we did earlier here to determine what subnet, like if you are PCA, you're trying to determine what subnet you're in. We know we can do that just based on our IP address and mask. Remember that?
Mm-hmm.
Right. So imagine doing that same exact process several times, once per interface on a router. So each interface of a router has an IP configuration. And for each interface, you're thinking, okay, what is this interface's like subnet prefix? Okay, and what about that one? And what about that one? So based on that, the router already knows, like, it knows, like, if it's connected to 3 subnets, it knows routes to 3. It knows how to route towards 3 subnets. Correct?
Yeah.
So what it will do is, based on the IP configurations of its own interfaces, it will create routes in its routing table. Right? So automatically filling out a little bit of its routing table. So thing to remember here, by default, a router will automatically fill out its routing table based on the subnets it's connected to. All right, so Scout, I know you have this you take notes and all of that. Be sure to write that down because that's going to be really important here.
Okay.
So yeah, it's the important bit is that it automatically fills out its routing table.
Okay.
Next question is, what the hell is a routing table?
Does it base the ordering in which it basically finds out what's closer and what's farther based off how long it takes for the ping to go round trip?
Not quite.
Okay.
Not quite. It's more like a table of, here's the destination and here's how to reach it. Now, there is an idea of distance, but I don't actually want to go into it tonight.
Okay.
Because it can get, routing in itself can get pretty complicated, and I think I'm gonna finish the routing class probably next week because I realize there's a lot more to it. But before we stop, I want us to at least have a look at the actual routing table. So let's just skip over and just go over to this immediately. Now, actually, no, I'd rather make it manually first. So a routing table is a set of routes. And a route is pretty much just 3 informations. It's an IP, it's a mask, and it has sort of a an exit. So the exit would either be an outbound interface, so the interface by which the packet has to exit, or a next hop, which would be like the next crossroads, or more precisely, the next router that you have to reach.
Okay.
So in our example here, the route that we want to give to A would be something like this. So so a route is, we have to give a destination, right? We have to describe it to provide a destination. We have to give a mask, and we have to give an exit. We need those 3 informations to create a route. And we're manually going to create that this time. So we're going to say the destination is going to be D, because by destination we mean when someone asks you for this destination. So D, that would be IP address 10.0.0.0. The mask would be, well, the mask for D again, so that would be, because it's a /8, what's the mask for /8? If I was to fully write it out.
255. Right?
And yeah, 255.0.0.0. Correct.
Okay.
Yeah.
Yeah, you actually have to specify the zeros afterwards.
Okay.
But yeah, that's correct. And then what would be the exit? Or sometimes we can also call it the next hop. Again, this is for router A. We are configuring router A here.
The router B?
Yes, absolutely. So this sort of works like a gateway in a sense, except it's a little bit more specific. It's like a conditional gateway. You know, a gateway is like, oh, always send if I don't know where to send the packets, always send them to that guy, right? That's the gateway. A route is like a more specific gateway. It's like, okay, you're not always gonna, like in this case, we're not always gonna send the packets to B, but it's sort of a redirection, right? And it sort of acts like a gateway. Does that make sense? Or is it a bit confusing?
I mean, it makes sense. It's just I have to think about it a little harder.
Okay. So let's follow our example here. Now let's try again to send that ping, that letter. So first of all, the letter gets sent to router A because we have configured our gateways properly in the subnet A. And then router A looks at the destination, right? And the destination, so again, it's meant for subnet D. So the router A looks at the destination, sees that it's destined to subnet D. It looks at its routing table, and in its routing table, it finds an entry that matches. It finds that, in fact, it does know how to reach subnet D, and then it looks at how, and it sees, oh, I just have to pass the packet to router B, and then router B will do whatever it wants with it. It's not going to be my problem anymore. So router A will redirect the packet to router B. And at that point, router B is part of subnet D, right?
Oh, okay.
So router B actually does know how to reach the destination. Does that make sense?
Yes. Because it's part of the subnet, so it's...
Yeah. And in fact, I'm going to be going a little bit more in detail here and tell you that In fact, this process that I just did of filling out the routing table, like I explained earlier, this is actually done by default with the interfaces. So for instance, by default, without you having to touch anything, router A already has routes for subnets A, B, and C. So for instance, subnet A, it knows that the exit would, for instance, so I'm going to give the interfaces, I'm going to give them numbers so we can identify them. So interface number 1, interface number 2, interface number 3 on router A. And so we know the exit would have, for instance, would be the interface 1. For subnet B would be interface 2. For subnet C, interface 3. Does that make sense?
Just reading through it real quick. Let's see.
So these
yes,
are those
Oh,
are
God.
automatic. Those are
Yeah.
automatic routes. You don't have to manually enter them. They are automatic.
It doesn't have to sort them through the routing table. It just knows them.
It's more like it's automatically going to fill out its own routing table based on how you configure its IP addresses. Like you configure its IP addresses, therefore it knows what subnets it's a part of. Therefore it can make conclusion, therefore it knows all those subnets already, and therefore it can fill out its routing table.
So our ISP has an enormous list of all the routers that exist, and they check the list every time that they need to send you a package of information.
Basically, yes.
Oh my God.
Every single packet that, I mean, it's a little bit more specific than that. If you want to get very specific, without getting too technical, basically most routers, enterprise routers, have sort of caching technologies where if you send one packet towards a destination, so there are two ways of doing it, but fundamentally, it's like, imagine you're gonna send one packet to a destination, and it's going for the first packet, the router is going to think pretty hard and look through its routing table. And then every other packet towards the same destination, the router has cached some of the information about the packets you're trying to send and doesn't have to do all the thinking again. So the process is a lot faster.
But
that by the way, those technologies are fucking fantastic. They're incredible. They're really hard to explain. They're not even CCNA level. Those are technologies that are more like CCNP level.
Which is the step above that, I'm guessing.
Yeah, what we're doing is not even it's. I'd say I think we're trying to reach basically half of the CCNA with this series, maybe less than that. So CCNP is way above that.
Wow.
Yeah, we're not there yet, but it's really cool though. There are a few things that are pretty cool. Anyway, but so the idea is, for now, we can imagine that every single packet has to be routed through the routing table. That routing table by default is only filled out with the subnets that the router currently actively knows, it's connected to, and we can manually add routes to sort of extend that knowledge. Now, trick question again. If I was to really, let's say I configured router A, and router A does have now a correct route to subnet D, and I was to ping from somewhere in subnet A to somewhere in subnet D, would the ping pass? And obviously remember that the ping is a round trip.
going through the gateway and let's see. Is the gateway properly set up to bring the message back to A?
Yes. The
router
terminal,
yes, it should.
the
Then it should.
terminals are all properly configured. The PCs
yes,
are
it
all
should.
properly configured.
But the routers are properly configured?
I don't know. You tell me. We've
No.
configured A. Okay. So, okay, let me put it this way. You said yes, we can send packets from A to D, from subnet A to subnet D. Can we send packets from subnet D to subnet A?
No.
I guess B has to be configured because of its routing table.
Well, does B know subnet A?
No.
By default, again, assuming we haven't done anything. No, it doesn't. So this thing of adding an extra route in the router A's routing table, so we just added one route for one router, we need to also add routes for router B. We need to give it routes to subnet B and subnet A. Otherwise, B has no idea. Router B has no idea what where those subnets are. So this process of adding one singular route on A, we need to do it 2 more times on router B. Does that make sense?
Yeah.
So again, always try to think of a router as having very limited vision. And all the routers need to have a vision of the entire city, of the entire map, for us to really have proper IP connectivity. So we just gave vision to A. B still doesn't have vision, and we need to provide that vision. Does that make sense?
Oh, sorry, I was muted. Yes.
Yeah.
Okay. How are you feeling so far?
I'm gonna definitely need to go back over the notes a little bit, just to make sure that I have the entire routing done from A to B and back, because that I think is gonna be my main downfall right now, and I get it to a degree. I just need to figure out how to set it up properly, and once I do that, I should be fine.
Sure. So what we can do, if you want, at some point, we can go over this again and try to configure it. Now, one issue we are going to have with the configuration is because we're using Cisco Packet Tracer, the configuration is actually going to be a little bit difficult because we're going to have to go through the command line.
Okay.
However, it's not that complicated. It's like you basically need to know 3 commands. One command is to have privileged access on the routers. One command is to show the routing table, and one command is to add a route. And I've spelled them out entirely in the PDF, in the presentation. So my goal here is not to teach you how to use Cisco devices, because that's not at all the point. And if you're using home router software such as pfSense, which is a very popular one, also serves as a firewall, but a firewall is basically a router. Those are fundamentally the same thing. Adding a route to pfSense, you have a very nice graphical interface, and you don't have to go through a command line. But for the sake of using Cisco Packet Tracer, we will have to do a little bit of command line. Just to, just to add the routes.
That's not the worst, but yeah.
Yeah. Second thing, before we close here. In practice, in the real world, what we are doing is called static routing. Static routing. Can you take a guess as to what would be the opposite of static routing?
Dynamic?
Dynamic?
Exactly,
Yeah.
dynamic routing. So dynamic routing is a set of protocols that allow the routers to directly communicate with each other and to directly like share each other's routing tables. So like for instance, by default, router A knows networks A, B, and C. Router B by default knows subnets C and D. So B and A, routers B and A will start communicating. A will tell B about subnets A and B.
Okay.
And B will tell A about subnet D. And all of that will happen automatically. And then if for whatever reason, subnet D, for instance, becomes unavailable, subnet B will update the information for router A. Router B will update the information for router A, telling him, hey, by the way, this subnet, yeah, it's no longer available. So all of that is dynamic routing.
God.
I'm not going to get into dynamic routing here because that itself is a whole can of worms. And again, for most intents and purposes, it's not going to be useful to us. Even if you do a home lab, and even a fairly consequential one, either static routing will be more than enough, or you won't even ever need to like manually fill out a route, like a routing table anyway. Dynamic routing becomes in my experience, dynamic routing becomes a necessity when you start having more of an enterprise design for your network. But if all you have is like at most 2 or 3 routers, you probably don't need dynamic routing.
Okay.
And if you only have the one, then you definitely
And wait,
don't.
isn't also static routing, doesn't it technically give a more permanent IP address that basically gives a more dedicated signal, or am I thinking about something different?
I'm not exactly sure what you're talking about, and I don't really understand. Dedicated signal, what do you have in mind exactly?
Well, I just remember when I was reading about stuff, you could change the I forget what you could change on your router to make it where it doesn't
dynamically
change your IP
Okay,
or
yeah. Okay, so this is more about another protocol that we will see soon called DHCP.
Yes, that's what I meant. My bad.
Okay. So DHCP is not a routing protocol.
Okay.
Okay. DHCP basically, so to give you a brief idea, you see how we've had to like manually configure our PCs thus far with IP addresses, masks, and gateways? Do you expect like your like 90-year-old grandma to do that? No, you probably don't. Right. You don't expect.
She's 6 feet under, so I don't expect it.
I mean, you certainly don't
I'm just
expect
kidding,
everyone.
but no.
You don't expect everyone to like have knowledge of IP networking and to be able to properly configure their IP addresses. So you need something that's going to automatically configure IP devices. That way you just have to plug the Ethernet cable and then you're on the internet, and that's it. That protocol that configures your PC dynamically is called DHCP. And just by saying this, that's pretty much 90% of what I wanted to say about DHCP in this lesson anyway. Like we don't have to go too much in depth. It automatically configures your PC.
Okay.
So what you have in mind is, and yes, the DHCP starts from your router as well. So that's why you'd go on your router, you'd change a few options, and suddenly your IP addresses are more, let's say they're more fixed. But again, we'll have plenty of time to talk about that another day.